right, just waiting for the audio to kick in there. Hey everybody, how you doing? Hey, who doesn't like lunch, huh? How was that? That was a pretty good lunch. What do you think? No dessert? I can't help you with that, but that's probably one of the best lunches I've seen at a conference in a while. They did it really well. I'd like to put my hands together for those people. That was fantastic. And since we're clapping, whoa, this thing's high gain. Since we're clapping, let's also put our hands together for the wonderful people from Mikrotik for putting this together finally, getting Canadian users together in the same room. I think that's awesome as well. So I'll clap to them. Thank you. This thing's got a lot of kick, and trust me, I talk on a lot of PAs, so if it goes all tinny or whatever, that's not me. I got nothing to do with that. I'll be honest with you. The slides I have are short. I'm not going to get super technical. I'm glad I followed the last guy who talked about WDS, so I don't have to get into the details of WDS. You clearly got a schooling on it last time, so I'll just tell you how I used it and how I arrived at my outcome. All right, so a little backgrounder. Well, who am I? Why am I here? My name is Pepin Woolcock. I'm a Mikrotik user, probably the last 4 or 5 years. I got into it because I operated a small network. Basically, I was given an opportunity to deploy a network for a nonprofit housing organization who had about 3 buildings spread over 2 or 3 kilometers in a weird area. And at the time, they were giving internet access to their low-income tenants, and they were trying to manage it through a mishmash of cable modems at each location. So they stuck in a cable modem and a router, and they said, good luck to you. Let's see what happens. Well, it wasn't working out so well, and they needed a solution that would really bind things together and create an experience that the residents could enjoy. So at the time, I had a PF Sense system going, and we deployed some point-to-point wireless and connected the buildings together, and we decided, well, that should work. Let's see what happens. Well, I'll tell you, it's not that simple. Anytime you try to take many users in many different broadcast domains and stick them together on a switch and just say, have a free-for-all at the pipe, it's not a good situation. We learned quickly that traffic management is really the key to making these things work. Well, a lot of different types of management, address management, so on and so forth. So basically, making a long story short, I was using PF Sense. I had some secondhand Cisco equipment. Any Cisco guys here in the house? I see a couple of hands up there. Yeah, a few, thank you. Okay, we're about Mikrotik here. So yeah, we had some secondhand Cisco equipment, and we bound it all together to see what happened. And it worked okay, but I didn't have any control over the address ranges of the groups. We didn't have the ability to really put any equipment at the edge, so we couldn't deploy addresses or hand them out at the edge. So in the building or at the suite level, we were just doing one big broadcast domain across 3 buildings. And if you know anything about routing or engineering, it's probably not the best way to go. You would experience things like DHCP timeouts. People are trying to get an address to get on the internet and there's no addresses to be had, or it takes too many retries, you have drop packets. We needed something better. So I had done some reading at the time, and I saw these newfangled devices, well, 4 or 5 years ago, Mikrotik coming out. They were based on Linux. I have a deep love and understanding of Linux, so already I was like, that sounds cool. They had every port. Well, you know all about the product. I'm not going to talk about it till the end of the time, but every port was an Ethernet device, and I love that idea. So I really delved into that. And since then, I've been just deploying Mikrotik stuff. I ended up building a small WISP in my area. And one of the projects we undertook, which I'm here to talk about today, is this, Mikrotik for public open access deployments. What does that mean? So there's a downtown core we have, and most cities, small cities like the one I live in, Guelph, Ontario, it's about 100,000 people, has a tiny downtown that's trying to find an identity, and it's trying to drag people in every which way they can. And one way we thought that we could bring users into the downtown was to offer them free wireless internet, maybe something, some reason to come down, some reason to stay longer, you name it. So we undertook this project, given that we already had resources in the downtown to make that happen. We had some basic backhaul. We were able to drag our internet connections from the downtown to a location. So let's build something. So without further ado, slide 1. What was the project? Well, I just covered that. Build a public wireless network, cover a small metro space, work with or work around buildings. When I say work with or work around buildings, I'm talking about the inherent logistics of point-to-point, trying to do a connection around a corner, so to speak. Not always possible. And support the widest variety of client devices. So one thing I'll say from my own experience, that it's fine when you're doing like a Mikrotik radio to a Mikrotik radio or a Ubiquity radio to a Ubiquity radio, and you can even kind of mix and match. But sometimes when you're talking about edge client devices, you can't always pick what the person has, right? Some people have old Blackberries or third generation Apple devices, and all of them have their own little strange quirks about how they join a network, how they signal, how they sit around, so on and so forth. So we had to work some of those things out. And you can see the picture there. I have one of their new cloud router devices and Groove there. I'll get into that. Some of the challenges. So clients need to be able to roam from AP to AP. So when you're trying to create a continuous environment, you want that when they walk down the street, they roam to the next closest AP, and hopefully they disassociate from the last one as well, not causing a conflict. Hand out portable addresses. So we can't hand out private address spaces on each tube or each access. Like imagine if every 10 feet there was an access point, and every time you got farther away or closer, you had to drop your address and pick up a new one. It doesn't work very well, especially when you're talking about a streaming connection like Skype or even well, maybe YouTube would do it, but that's a different story. Anything that requires you to have a constant connection is not going to like that you drop addresses and hand them out. So we have to be able to hand out those addresses at multiple places and allow those clients who we've previously handed out addresses to be able to continue using them no matter where they are within the network. And of course, one of the requirements we had from our project itself, who we deployed for our business improvement area, so that being the little downtown core, was that people who got on the internet had to see a landing page first. So they had to agree to some basic terms like, don't use this poorly. Don't use this for whatever, the host or myriad of things that you say you're not supposed to be able to do online. So we had to prompt them with that before they got a chance to access. So as I just covered, the target customer, why we deployed this was for our local BIA. And there are BIAs everywhere, business improvement areas, little downtowns that are looking to do the same thing, buildings, shopping malls, you name them, they're everywhere. They were wanting to offer free wireless access to their visitors. So the deployment technologies, what did we do? We used Mikrotik devices, and we had to come up with our own design to do that. So what we actually did was we developed, it doesn't sound good when you think about it, but this is a tube. It was a plastic tube, basically, where we stuck two of, well, you can kind of see them up there. If you're familiar with the Groove device, it's kind of looks like a, I don't know, like a bottle of soda, one of those long ones, and you put the antenna on top. We put two of them in a plastic pipe and put pipe caps on them. And it was gray, and we just bound them together with a bridge in the middle, put one on 2 gigahertz, and we put one on 5 gigahertz. And the one on the 5 was our backhaul, and the one on the 2 was the client network. And we just stuck them up on the light poles, and I hate to say it, but they kind of look like pipe bombs, and no one wants to see pipe bombs in their community, but it worked. It was a sealed environment. We didn't have moisture issues, and they were easy to put up and easy to power with a common power source. So we did. I just described that. And the unexpected outcome, it worked. That was pretty awesome. So after we did this, and we deployed a few technologies to make it all mush together, so we put WDS on both sides, on the 2 and the 5 gigahertz network. 5 gigahertz, we had to play around with it a little bit more because if you saw the previous slideshow on WDS and other routing protocols, you'll know that when you engage a dynamic WDS network, every device that can talk to each other tries, and they will form strange routes. And you can turn on RSTP and other protocols to try and mitigate that. But sometimes in your environment, it's not perfect. So what we ended up doing was static WDS. And I'll leave that up to you to research how that works. But basically, every device kind of became its own, like an ether interface like you would have on your physical port. And then we set up a basic, what's that called? Where you, I lost the name, but it's a form of bridging where you basically say packets only flow one way on the bridge. We turned that on, And that worked out great, and it stopped the noise from A to B and C and D. And we also made the configuration of the radio static because we knew how close they were. There was no need for them to go and seek out who else and wherever else. We knew how it worked. We knew the best way, so we made them static. That was golden. So what else happened was it worked, and it was successful, and people are able to join, and we were able to tune in, and we worked out all the little details. You have to play with channel allocations. You have to play with DHCP times for various devices, but people were browsing. And then guess what happened? Other people wanted to also deploy their own wireless networks in the same space. Well, you have one success, so you have three successes. So at this point, we had an SSID that was broadcasting our free service, and we started finding other partners wanted to broadcast their own SSIDs in the same area, and some tried deploying their own equipment and failed, and so on and so forth. And it's not like we were trying to close it off. We just didn't really have a solution. We set out to do just one thing and do it well. So we had to hammer down and create another way to do this, so to create multiple visible networks. So we stumbled upon the virtual AP mode, which works really well. And if you turn that on, you're able to broadcast multiple SSIDs from your wireless devices. And I think the limit is, I think it's 255. I don't know, correct me, I've never pushed it that high. But you can deploy quite a few SSIDs. Mixing that in with a little VLAN, mixing that in with some VLANs and some bridges with our WDS network, and all of a sudden we had multiple distinct networks that were being handed out over our common architecture within the same area. I mean, that will always create new issues for you as a provider. We had to, get into technologies like MPLS and everything else to keep frame sizes, but that's beyond the scope of this discussion that I'm here for today. What it did do effectively was it allowed us to take people who were on the street, give them their own common private network by name, and then we could drop that network to a location of the customer's choice. So some of these other people who wanted to deploy networks in our area, one of which being a small coffee concern, wanted to kind of extend it out, we were able to take all the people who were roaming on their private SSID and dump their traffic to a router of their choice, either in their office, which we ended up doing, or in the core as a fallback. And by using technologies like MPLS, we're able to just shuffle those frames right to them, let them terminate them at their router, and then we also supplied them internet, so it's a double win. And that's why I love Mikrotik devices. So yeah, you can see my love here as I'm holding a cloud core device. I'm hugging it ever so gently. I would have, laugh it up, it's okay. I would have to say that discovering these devices, discovering software routable devices like this, being able to do things like traffic filtering, MPLS, VLAN, you name it on the same device is huge. And it's I think one of the greatest opportunities I've seen in networking in a long time. So, I'd like to thank the guys at Zagel here for letting me take a picture with their giveaway CCR, because I'm kind of holding it up. Don't worry, it's still, it's good in box, and whoever wins it, it's brand new. Right, so my final points basically, traffic management, I'm gonna wrap it up around that. So big, it's not even funny how big of a topic this is. I could talk to you for 50 minutes on traffic management and not even scratch the surface, but get to know it and get to use it, because the more you deploy it, the more it's gonna make a big difference and an impact of the quality of service that you're gonna deliver at the end. And there's no limit to the number of places you should deploy packet marking and traffic management, deploy it at the edge, deploy it at every core site, deploy it right at the point where you terminate internet, just keep redeploying it all over the place. It makes a huge difference. And don't be afraid to mark connections and packets. That's all part of traffic management. So I think that's it. I'm just gonna open it up to the floor. You guys have any questions for me? If I play Jeopardy music, will that help? No? Oh, I see some hands, sorry.
It's not a question, just a comment. I should say. I think it's really cool what you guys are doing, delivering very high-speed services like that. Did you get into anything else like related to the home paid services?
That's eventually the goal, but at this point and at this time, this is what we did. Yeah. Any question? Yeah, sure.
Do you have any picture of your pipe, your system?
My pipe bomb, you're going to say. I was looking for a good picture. I really should have taken some of them. I thought for sure I had taken some previously, but I don't have any pictures on me. I'm sorry. However, please feel free to write down my contact information up there. And if you'd like, I will send you some more detailed information, anybody who requests. Anything else from the other side here? So the gentleman asked, is the network all bridged or is some part routed or something? At what point, I would ask? Like throughout the full architecture? So I would say, I wish I had a whiteboard. I've been doing adult teaching for years. A whiteboard would be my best friend right now. But there's a core node on our WDS network that is the router, and it hands out the addresses from there. But all of the edge radios that the clients are actually roaming upon are not routed. They are completely bridged, and it's that core radio that's handing out the different DHCP networks in some cases. In the cases where we're doing full backhaul from the radios on the street to the client's presence, we are not handing out the addresses from that point. Their router, wherever that we have deployed it or dropped it, is handing out the addresses, and yes, it is like a complete layer 2 bridge, but the actual bridges within the devices will associate with the MACs, which will stop the noise of the bridge in general. So it still works out quite well. Yes? What do I do about people who leech Wi-Fi because they don't want to deal with the DSL? Well, I'm not going to use SCSI and stealing my Wi-Fi as a definition of the client base that I might perceive there, but I will say that traffic management is, again, that's the answer to that. So it's not that I have a problem with anybody using the internet or using it for any specific thing. I just want to make sure that everybody gets a fair share of the available amount of internet. And by using traffic management, I'm able to divvy up my bandwidth that I have at each access point so that everybody can get a shot. And that's on a per second basis. So. Have I found a way on my traffic management to block BitTorrent streams? Yes, but it's kind of a roundabout way. My preferred methodology to block BitTorrent is to first mark all the traffic that you want. And then anything that you didn't mark as the traffic that you want is traffic that you don't want. So it's likely BitTorrent. No deep packet inspection. I love cloud cores, and I deployed them initially for the point of being able to do things like that, like layer 7 inspection, but it didn't work out. It didn't make any sense, and especially thanks to the switch to SSL, it's useless. You know, back when I was doing it in the start, we used to squid cache everything because everyone was on HTTP. So, you know, intercepting connections and caching them, that was the way to go. But these days, thanks to SSL, there's no point in doing packet inspection. You simply mark the known types of traffic that you would allow for your network. So, I mean, it's kind of a short list, but like web, Skype, VoIP, I don't know what else, Telnet, SSH, just a basic gamut. There's about 30 or 50 ports I would say that people seem to use day to day. And then you put those in different traffic queues, and then you have like QZ. It's whatever's left over. And then you put that stuff into QZ. And then if you want to get rid of it, you just block anything that's in QZ. End of story. It's not perfect, but it works for me. Any other questions? Yeah, from the back. How do you stop visitors from hacking visitors, basically? Well, I would say that those who are on the free tier, we put them through the captive portal, and that seems to help a little bit. I've never really tried talking to another address on the captive portal, like captive to captive. I'm guessing there's a possibility of that, but excuse me. But also, given the way that the bridge flows only one way, so packets from this way can't cross back because I've used, I cannot remember what this is called. Split horizon, thank you. It goes back to the gateway. The gateway says, no, you're not supposed to talk to your neighbor, and then it doesn't forward it back to the neighbor. And that seems to do it for me. I know your mileage may vary. That's my best answer. Any other questions? Okay. How do you secure the network? In what, well, I think that was kind of his question. So in what sense do you mean? I'm not really sure to answer that. I mean, when you're talking about the free and the public network, I don't really have an answer for that. There will always be malicious people, but even in a coffee shop, there will always be malicious people as well. One of the things that we did try, we tried deploying another SSID that did not broadcast a regular like IP domain. It only broadcasted a PPPoE server. And that was the intention, to try to bring in a paid deployment service that you could log into this other SSID and maintain a PPP session and then get a fixed amount of speed. In which case, then you can kind of do things at the gateway to try to stop packets from going from A to B. You can put in loads of rules and so on and so forth that stop neighbors from talking to each other. It's not widely deployed though. It is there, it works, but it's not widely used. So I can't give you a huge report on that, but I would say I'm also a big fan of PPPoE as a way to deploy addresses across your network. It's fundamental. Other questions? Sure.
I'm curious about volumes. How many users are you servicing?
Okay, so in the daytime, there's about on average 50 to 70 people, let's say, on the network during the day, or client devices. They may not all be using the internet, but they all register because it's a non-passworded AP, so devices like to automatically join. At nighttime, which is really the celebrity, if you want to say, of our downtown, all the students come downtown for the 17 bars or whatever that there are, and the numbers really surge. So we've had to deploy a few more tubes in some areas to kind of make up for that, because there is such a thing as like AP saturation, right? And we've also had to deal with things like rolling down the power on certain APs so they don't talk over each other and cause a different kind of saturation condition. We actually had one situation where we had the power too high, like the gain too high on both antennas, and it was causing the device to overheat in the tube. It was running in excess of like 64C or something, and I know the device says it's rated to 80, but that's not true. It crashes at 64, it crashes hard. So you don't want that. You gotta bring those temps down. You gotta bring those temps down. There's no active cooling, it's completely passive. Sorry, I forgot your question a little bit though.
You answered part of it. What's your peak load?
Oh, peak load. So at night, yeah, it surges right up. Could be 200 plus or more. I'm sure there's more devices that are maybe getting on. Maybe some are getting dropped. I've never really walked around in those sections while those people are on to see if I'm unable to get an address. However, I do hand out a rather large swath of addresses, so I don't think it's address exhaustion. I think that's just the peak number of devices seeking an open network. We have two bonded DSL, 25 and 10, so we got 50 and 20 basically, and with traffic management, that's more than enough. Yeah. Questions? Oh, I see another one. I'm not saying I got all of that right away, but I would love to talk to you more about that, I guess, after the presentation. Oh, okay. That's great. There's lots of tips out there. It seems I'm not the only one who's trying to do this. Just out of curiosity, how many other people here have deployed some sort of public or open access network in some way? Oh, so this is a popular topic. All right. Anybody experience any of the things that I discussed already? Is this pretty common? Is it just by a show of hands, some of this? No? Really? What's your biggest problems? I'm curious now. I'm just going to open up to the floor. Sorry? Getting through concrete and rebar, that is a problem. Oh, concrete, yes, okay, that's true. We have a lot of stone also in Guelph. That's just a lot of fun. Some other problems, we talked about split horizon bridging, we talked about security. I don't think there are really great answers for everything. I don't think there's such a thing as a magic bullet, but this network has been running for over a year, and it still continues to run, and hacking attempts or people making fraudulent frames and saturating nodes, these haven't been things that we've had to deal with. I don't know if my solution covers enough of those problems to stop those attacks, or if simply we just haven't experienced them yet, but I would say, you know, I'm pretty happy with the outcome on this one, so. I guess if there's no more further questions, I'll say thank you, and I really appreciate your time and you guys listening to me today. Thanks.